can transform this graph using some functional transformations. So I've drawn a graph in blue of a function we'll call f of x, and our attempt is going to be to draw f of 2x in green and 2 times f of x in red. Now f of 2x, the 2 is in there with the x, so this is going to be a horizontal effect, and the effect on the horizontal is this is going to be horizontal compression. Think of the 2 as a lot of weight, so what that's going to do is it's going to take the picture and compress it in a horizontal sense. So right now we have a point that's located, let's say this one that's on the left has an x coordinate that looks to be about -2, so if we horizontally compress by a factor of 2, it's going to be moved in to about there, to an x coordinate of -1. Notice that the y stays the same, no change there. The second point has an x coordinate of 0, so it's just going to stay at 0 because half of 0 is 0. And then the other point, the third point, has an x coordinate of positive 4. So when we compress that by a factor of 2, it's going to move to positive 2. So we get a point that goes there. So the horizontal compression graph that compresses things horizontally speaking will look like this and like that. So it's kind of like it's squeezed in from both sides in order to create that graph. Now 2 times f of x, the red graph, is going to be a stretching factor vertically, because now it's not with the x, it's on the outside, so we get a vertical stretch factor, which means it's going to take the original blue graph and every one of the y coordinates is going to be doubled. It's going to be twice as large. So again, with that first point, now looking at the y coordinate, the y coordinate is -2, so if we double that, it's going to keep the same x, but it's going to go down to here, which is like a -4, right? -2 doubled is -4. 0 gets doubled to be 0, so that's still going to be in the same spot. And then the other point, which was located at a y coordinate of -2, is also going to be doubled to become -4, keeping the same x coordinate. So it's going to go right about there. So this graph is going to look like it stretches from here to there, and then this one is going to stretch sort of from there to there. So unfortunately the greens and the reds kind of overlap themselves a little bit here, but we can see that the green and the red are just happen to be kind of close to the same spot, and we get our graph. Okay, so notice how we have a stretch on the red stretches the blue, the green compresses the blue. So pause the video for a second and see if you can do these ones exactly backwards from what we just did, because they're going to go in the other directions. So assuming you paused here for a moment and tried it on your own, we now have an f of 1/2 of x. So before we had a horizontal compression, this is therefore going to be a horizontal stretch. It's not going to compress, it's going to stretch. So right now this point, which has an x coordinate of -2, is going to be stretched out to an x coordinate of -4. This one has an x coordinate of 0, so it's going to stay at 0. And this one's x coordinate is 4, so it's going to be stretched out to a value of 8. So this graph is going to come in like there and like there. So we have a horizontal stretch in our picture. Now on the other hand, 1/2 of f of x is going to be a vertical, this time, compression. It's going to squish it down. So we're going to take the y coordinates and we're going to half them. They're going to become half as dominant. So here the y coordinate is -2, half of that is -1. Here the y coordinate is 2, half of that is +1. And here the y coordinate is 0 and half of that is just 0, so that one's going to end up being at the same spot. So when we perform our stretch factor, which I guess is a compression factor, vertical compression factor, we end up getting the red graph. So notice that the blue was stretched horizontally to become the green, and it was compressed vertically to become the red. Two different types of transformations.